It's already 5. Let's wait for a few more. Good evening. Maybe we will wait 1 to 2 minutes, then we will start. I will just share the slides, see if it is visible properly. Is it visible? Is the slide visible? Okay, I think we can start now. So, welcome to week 1 tutorials of the NPTEL course Pericyclic Reactions and Organic Photochemistry by Professor S. Shangaraman from IIT Madras. Myself, Anisha Suresh, PMRF TF for this course from IIT Bombay. So, first, we will have a brief discussion regarding what is pericyclic reactions and majorly electrocyclic reactions. So, coming to pericyclic reaction, so it is the cyclic redistribution of bonding electrons through a concerted process. So, pericyclic reactions are concerted process which involves a cyclic transition state where the redistributions of electrons will be taking place. So, the main feature of this reaction is it involves no ions, free radicals, or catalyst, and these reactions will take place under extreme temperature or photochemical conditions, and they involve this molecular orbital symmetry. And pericyclic reactions are very stereospecific in nature. And it was Hoffmann and Woodward in 1965 who explained pericyclic reactions for the first time. So the term pericyclic means it is the transferring of electrons around a circle. So since pericyclic reactions involves a cyclic transition state and it is a concerted process, thus it got the name. Okay, and pericyclic reactions can be classified into 5 types. So what are those 5 types? Electrocyclic reactions, cycloaddition reactions, sigmatropic reactions, chelotropic reactions, and group transfer reaction. So, in the first week, Sir have discussed regarding the electrocyclic reactions. So, we will focus majorly on questions that are based on electrocyclic reaction concept. So, coming to electrocyclic reactions, electrocyclic reaction is a concerted cyclization of a conjugated pi electron system by converting one pi bond to a ring forming sigma bond. So, if it is a conjugated pi electron open system, then it will form a ring leading to the formation of a new pi bond at the expense of a new sigma bond at the expense of a pi bond. And if it is taking place in the other direction, it is called a electrocyclic ring opening. So you can see this is 1,3-butadiene So this is a 4 pi electron system. So it can undergo electrocyclic ring closure, resulting in the formation of this cyclobutene. Okay, and if cyclobutene, it is this sigma bond is getting broken, it will get converted back to 1,3-butadiene. So here we will be discussing like how these reactions are taking place and why the electrocyclic reactions are stereospecific in nature. So for discussing that, we know the pericyclic reactions can be analyzed by three different methods. So FMO is one such method, that is FMO, Frontier Molecular Orbital. So out of the three methods, one important method is the Frontier Molecular Orbital method for analyzing the pericyclic reactions. The other two methods are the transition state aromaticity method and orbital symmetry orbital correlation method. So now coming to uh, how the pericyclic reactions are defined for the 1,3-butadiene under thermal condition and photochemical condition, that we will be discussing. So before that, we should know what are the frontier molecular orbitals for 1,3-butadiene. So I will be drawing the frontier molecular orbitals for 1,3-butadiene. So it will be having four FMOs. So in the this FMOs can be named Psi 1, Psi 2, Psi 3 and Psi 4. Okay. So Psi 1 will be having number of nodes equal to 0. Psi 2 will be having number of nodes equal to 1. Psi 3 will be having number of nodes equal to 2. And Psi 4 will be having number of nodes equal to 3. So according to that, we will be giving the shading. So in case of Psi 1, there is no nodes. So all the lobes will be having the same sign. In the case of Psi 2, it will be having one node. So according to symmetry, the node will be here. So this will be shaded in this fashion. Okay. And in case of Psi 3, there will be two nodes. So according to symmetry, we will consider the nodes at these position. So the nodes will be like that. This will be there will, since there is no node here, the lobes will be of the same sign, and here will be this. Okay. And in case of psi 4, it will be having three nodes. So between each bonds there will be a nodes. So one, and we know in the case of 1,3-butadiene, say four electron system. So the electrons will be occupying the FMOs in this fashion. So in the first psi 1 and psi 2, the electrons will be occupying, and these two will be empty. So this is psi 2 will be the HOMO, highest occupied molecular orbital, and psi 3 will be the LUMO, lowest unoccupied molecular orbital. This is the ground state electronic configuration which we will be following for thermal method. Okay. So when we consider the thermal electrocyclic ring closure or ring opening in the case of 1,3-butadiene or cyclobutene, we will be considering Psi 2 as the HOMO. So this is the HOMO of butadiene, that is the highest occupied molecular orbital, and it can be drawn in this fashion also. Both are valid. Okay. Any doubts? Okay, if there are no doubts, we will move forward. So, for the electrocyclic ring closure to take place, in order to form the new sigma bond, the lobes of the p orbital on C1 and C4 must rotate such that they have constructive orbital overlap. So, we will be considering the HOMO of 1,3-butadiene, that is site 2. So, this is site 2 where there is one node. So, for the formation of the new sigma bond by means of electrocyclic ring closure, the lobes with same symmetry should overlap. So, if we are doing conrotation, that is, if we are doing the rotation in the same direction, that is, this lobe is moving in the clockwise fashion, this is also moving in the clockwise fashion, then these two lobes with the same shading, they will overlap and result in the formation of the new sigma bond, that is, a constructive orbital overlap is taking place here. Okay, so that is why in the case of 1,3-butadiene thermal ring closure, we will follow conrotation. Okay, that is orbit if like this rotation will be taking place in the same direction, either clockwise or anti-clockwise. These both are conrotation. We will consider the rotation which will be giving a constructive orbital overlap. Okay, now coming to the case of photochemical electrocyclic ring closure. So in the case of photochemical condition, we have seen the four lobes. Psi 1, Psi 2, Psi 3, Psi 4. So, in photochemical condition, that is under the irradiation of light, the electrons that will be previously occupied at the site 2, it will excite and it will go to the site 3 FMO. So here now this will be the HOMO and Psi 4 will be the LUMO. So in case of 1,3-butadiene photochemical condition, HOMO will be site 3. Okay, then when we will be considering the ring closure, we should consider rotation that will give a constructive overlap based on site 3. So here site 3 will be the HOMO, and for constructive orbital overlap to take place, the both lobes should move in opposite direction. Like if one of the lobe is moving in clockwise direction, the other lobe should move in the counterclockwise direction so as to form or give a constructive orbital overlap leading to the formation of a new sigma bond. Okay, so this as we can see, both the arrows are moving in the opposite direction. Such type of rotation of orbital is known as disrotation. Okay, so because of that, for an electron, photochemical condition, that is H nu condition, this rotation is favored. It can be like clockwise, counterclockwise, or counterclockwise, clockwise. Both will lead to formation of new sigma bond with constructive orbital overlap. So I hope this concept of conrotation and disrotation is clear to everyone. Most of the questions on this electrochemical part will be based on this concept of conrotation and disrotation. So based on this concept only, Woodward-Hoffmann rules were derived. So if there is foreign electron system and it is conrotation, then under thermal condition it is allowed, and under photochemical condition it is forbidden because of non-constructive orbital overlap. In the case of foreign um, electrons and this rotatory mode of reaction, then thermally it is forbidden and photochemically it is allowed. And similarly, if we are having cyclohexatriene sort of system, like this sort of system, and if we will draw the FMO for this cyclohexatriene, we can derive this 4n plus 2 conrotation and disrotation as well. So 4n plus 2 conrotation, thermally it is forbidden and photochemically it is allowed. And 4n plus 2 disrotation, thermally it is allowed and photochemically it is forbidden. So this, if you are keeping in mind, you can derive all the other rules. Okay, so 4n delta will be conrotation. That if you are keeping in mind, then you can derive the other rules. So then 4n plus 2 delta will be disrotation, and 4n h nu will be disrotation, 4n plus 2 h nu will be conrotation. So this is the key concept that you have to keep in mind while solving the problems on electrocyclic ring closure and ring opening. Okay, any doubts? Is the concept clear? Hello. Okay, if there are no doubts and it is clear, we can move to first question. So this is question number 1. Predict the orbital involved and the rotation it goes through in the following cyclization reaction. So this is a 1,3-butadiene system and it is undergoing electrocyclic ring closure reaction leading to the formation of this cyclobutene. Right. So which is the orbital that is involved? Psi 1, psi 2, psi 3 or psi 4? And what type of rotation it will be undergoing? Option A, psi 2 conrotation. Option B, psi 2 disrotation. Option C, psi 3 conrotation. And option D, psi 3 disrotation. Anyone?
Side to A connotation. Number one option.
Yeah, option A, psi 2 conrotation will be the right answer. So we have seen here it is thermal condition. And in thermal condition, from ground state, HOMO will be considered. Ground state HOMO will be considered in case of thermal condition. So the HOMO for 1,3-butadiene in case of um, thermal condition is psi 2. HOMO under thermal condition. And we have seen that So this is the side 2. And for orbital overlap to take place, rotation should take place in this fashion, same direction. Then only these two orbitals will be overlapping, leading to formation of new sigma bond. Okay, side 2. So this is known as a rotation in the same direction is known as conrotation. So the correct answer will be side 2 conrotation. Is this concept clear?
Yes.
Okay. Now coming to question number 2. So this was a question from JAM 2021. So here an hexatriene system is given. So the major product formed in the following reaction is, so it is a thermal condition and it is 6 pi electron system, that is 4n plus 2 system.
It is B.
Option B, yeah. So coming to the explanation, so in case of hexatriene, so the system will be 6 pi electron system, that is 4n plus 2 system, and here the temperature is given. So it is thermal condition. 4n plus 2 delta will be disrotatory mode of reaction. Okay, for that, if we see the HOMO of hexatriene, that is side 3. One. So in case of side 3, there will be two nodes. So the nodes will be at these two centers according to symmetry. So for constructive overlap to take place between these two orbitals at the terminal atoms, terminal carbons, the rotation should take place in this fashion. If one is moving anti-clockwise direction, the other should move in the anti-clockwise fashion, leading to constructive orbital overlap. Okay. So since both these arrows are in the opposite direction, this is known as disrotatory mode of rotation. So this is the key thing we have to keep in mind. 4n plus 2 thermal condition disrotation. So that we will be following. So if disrotation is followed in this system, so this medial which is E, it will come above the plane. Similarly, this medial which is also E will come above the plane. So option B will be the right answer. Correct?
The slide is not visible.
Slide is not visible.
Hello?
Hello?
No, the slide is not visible.
Okay, let me see.
No, slide is not visible.
Not visible.
And now it is coming.
Okay, okay. Maybe some internet issues. Now is it clear? Is it visible?
Yes, now it is visible.
Okay. So this is the concept. In case of hexatriene, it is a 6 pi electron system. So it will come under 4n plus 2. And here it is 170 degrees Celsius mentioned. So it will be thermal condition. So in case of 4n plus 2 delta, according to Woodward-Hoffmann rule, it will follow this rotatory mode of reaction. So that will be coming from the concept of HOMO of hexatriene, which is side 3. So for constructive orbital overlap to take place in case of side 3, these lobes should move in opposite direction. One is moving clockwise direction, the other should move in the anti-clockwise direction, so that constructive orbital overlap will take place. So here, in case of disrotatory mode of reaction only, this is possible. That is the constructive orbital overlap will be possible. So,
তিনজন জয়েন করেছে।
hello.
সব স্টুডেন্টরাই পড়ে, স্টুডেন্টরা কেউ নেই, আমি পড়ে আছি।
So that is a key thing we have to keep in mind. So now coming to our question. So this is our starting material and it will undergo um, thermal electrocyclization. So it will follow disrotatory mode of rotation. So for the, when it follow disrotatory mode of rotation, this methyl group will be coming above the plane and this methyl group will also be coming above the plane. So it will result in the formation of B. If we follow rotation in the other fashion, like now if we are following like this, then the product that will result will be both of the methyl groups will be below the plane. Okay, that is also a possible answer. So the right option will be B. Answer will be B. Clear? Concept is clear now?
ইয়েস।
Okay. Let me try to move it. So the answer will be B. Now coming to the
হ্যালো,
hello.
হ্যালো, হ্যাঁ, I just want to know a thing. In your assignment, there are I think 7 or 8 problems. So if if I write it in the paper and then I scan and upload, then it will be acceptable, no?
Yeah, it will be acceptable.
Okay. Thank you.
Now coming to the next question, that is question number 3. So this is a question from CSIR net December 2011. So here they have given the system and it is undergoing thermal process. So what will be the product that will be resulting? So here this is the system that we will be considering. It is a 4 electron system or 4n system. 4n delta.
Foreign system.
Yeah. Right. 4n system, right. So for and delta, that is it will undergo thermal process, then it should follow conrotation according to Woodward-Hoffmann rules. So what will be the products that will be formed in this case?
It will be B.
Yeah, B will also be there, C will also be there. Conrotation can be either clockwise or anti.
B or C. Yeah, it may B or C. Yeah.
Mhm. So it will be like this. Under thermal condition. So if we are rotating it in clockwise fashion, this bond will this bond which is above will go outside. Sorry. This bond which will be above, it will go outside, leading to medial at this position, and this medial which is below, it will also be going outside. The hydrogen will be going inside, so the medial will be going outside. So it will result in the formation of product B. And if conrotation is taking place in the anti-clockwise fashion, that is this fashion, so the medial group which is above, it will go inside, and here the medial group which is below, it will also go inside because the hydrogen will be going outside, so the medial will be going inside. So it will result in the formation of C. So the right answer will be option B and C. Is it clear?
Yes, ma'am. You can proceed further.
Okay. Now coming to question number 4. The major product formed in the following reaction is. So it is a question from CSIR Net June 2012. So what is the concept that will be coming here? How many electron system this is?
4n
Six
plus
electron
2.
system. Six electron system.
Yeah, it is 6 pi electron system, 4n plus 2. So delta, what will be the mode of rotation?
Disrotation.
It will follow disrotation. So we can consider like hydrogen atom here, and if it is following disrotation, the hydrogen which is outside will be coming above. Both the hydrogens which is outside will be coming above. So it will result in the formation of 2 beta
A.
hydrogen, right?
Hmm.
And it is one ring will be 6-membered ring, and the other ring which will be
Five member.
1, 2, 3, 4, 5, 5-membered ring. So the right option will be option A.
Option A.
So here we have to follow this rotation. Sorry. Six pi electron thermal disrotation. So if the disrotation is taking place like in this fashion, that is clockwise, anti-clockwise, then it will result in the formation of A. If it is taking place in the other fashion like this, anti-clockwise, clockwise, so the next possibility will be both the hydrogens will be alpha. So these are the two possibilities. Since this is the option that is given, option A will be the right answer. Clear? Now coming to next question. The number of pi electrons participating and the pericyclic mode in the following reaction are. So here an octatetraene system is given, right? But what is the number of pi electrons that is participating in this reaction which will result in the formation of this product?
6 and this
Six.
rotatory it will.
Yeah.
6 pi electrons will be participating and it will follow this rotatory mode of pericyclic reaction. So according to Woodward-Hoffmann rule, 6 pi electron 4n plus 2 delta will be this rotatory. Clear?
Yes, ma'am.
It will be like on this system. It will result in the formation of a 6-membered ring attached to a 4-membered ring. So right option will be option D, that is 6 and disrotatory. So the key concept is 4n plus 2 delta disrotation. Now coming to the next question. Here two pericyclic reactions are involved, okay? So the following transformation proceeds through two consecutive processes which are dash and dash. So it came in CSIR net June 2016. And here they have mentioned the condition is thermal. So what will be the two different processes? So first we can ignore this part, okay? We will be considering this part only. So here it is a 1, 2, 3, 4. 4 an electron system, right? Or if we redraw it in this fashion, it will be easy to see like a 4 an electron system. Maybe this aromatic electrons are also involved. So it is a 4 an electron system in the first case. Hmm? So what will be the mode of rotation in that case?
First, it will be 4 pi con-rotatory,
Huh.
and afterward, it will be 6 pi disrotatory.
Yeah, option C will be the right answer then. So we will see similar question we will be like seeing later also. So first it will undergo ring opening reaction. So it will lead to formation of this intermediate, and so this is a 4n plus 2 system, right? This part 4n plus 2 or 6 pi electron system. So it will undergo disrotation under thermal condition leading to formation of, so this electron will shift, this electron will shift here, and this electron will shift here, leading to formation of this product. So first case will be foreign delta conrotation rotation, and the second case will be 4n plus 2 delta disrotation. Clear? Option C will be the right answer. Any doubts?
No, ma'am.
Okay. Now moving forward to the next question. So major product formed in the following reaction will be. So in this case, two methyl groups are also getting involved. So here the important thing we have to take into mind is the stereochemistry of the centers. So the concept is similar to that of the previous question. So here what we have to see is, the first thing that is taking place is 4n delta conrotation. Okay. So if we do conrotation in this fashion, this bond which is above the plane will be coming inside. This bond, this hydrogen which is above the plane will come outside, and this methyl will go inside. So we can draw it in this fashion. Methyl, methyl, and here this methyl will be, hydrogen will be coming outside, methyl will be going inside. Okay. Now this is a 6 pi electron system. 6 pi electron, 4n plus 2 delta disrotation. Okay. So here disrotation, if it is taking place, both the groups will be moving in the opposite direction. So the final product that will be forming methyl, so this which is inside will go downside, so it can be like alpha, and this methyl which is outside, it will go above the plane if we are rotating, so it will be like this. Okay. If we do rotation in the other fashion, like this is anti-clockwise and this is clockwise, then we will get this other possibility. That is, this will be above the plane and this will be below the plane. So which is the right answer? From the given option,
Option D,
option D will
D.
be the right answer.
Right answer.
Is it clear how we are doing the rotation?
Yes, ma'am. That's good.
Okay. Now coming to the next question, that is 8th question. So this is a name reaction. Sir have discussed in the lecture. Can anyone recall the name of this reaction?
Nazaro cyclization.
Yeah, this is Nasaro
Cyclization.
cyclization. So it is a pericyclic reaction involving pentadienyl cation and cyclopendinyl cation. Okay. Uh, so here what will happen first? So you can tell me what will be the product first.
I'm trying it.
Okay.
It would be B most probably.
Yeah, answer will be B only. So we will see the mechanism. So coming to the mechanism of the Nassarov cyclization, it will be like first in the presence of a Bronsted acid or
Nice
something,
acid.
it will get protonated. So it will be OH, okay. It will get protonated and it will result in the formation of this pentadienyl cation.
Hmm.
Pentadienyl cation. That will undergo a pericyclic reaction. So what is the number of electrons involved in this reaction?
4 pi electrons are involved.
4 pi electrons are involved. So when we will consider 4 pi electron cyclization, depending upon the condition, either it is thermal or photochemical, that we can decide the mode of rotation. So then it will undergo a pericyclic reaction leading to formation of this intermediate. Then upon
Mhm.
deprotonation, it will result in the formation of this system, and here ketoenol tautomerism can take place, giving the final product. So in our case, the reaction will be, so first it will get protonated in the presence of H plus, so it will give OH, and plus here is pentadienyl cation will be forming, and it will undergo cyclization leading to formation of this intermediate. Now deprotonation reaction will take place leading to formation of this intermediate, and then ketoenol tautomerism,
Automerism as well.
tautomeri- ketoenol tautomerism can lead to formation of the final alpha beta unsaturated ketone. So the name reaction is Nassarov cyclization. Clear? How we are getting the,
Ma'am,
yeah?
option D is not forming. The reason behind that is the double bond that is forming in the D is di-substituted. Is this the reason?
When we see, go through the mechanism, there is no such possibility of double bond coming here, na? Cation.
Ma'am,
Hmm.
in second intermediate after protonation of H plus, the arrow that you have done like
Okay,
that,
okay, okay.
if you go in just reverse way, then there
Yeah.
is a possibility
We,
of
we are
double
getting a
bond
tetra
formation at that
substituted
side.
double bond here, that which will be more stable. So
Yeah, tetrasubstitute.
hmm,
Okay.
that will be the reason why it is the major product.
Yes, ma'am.
So option B is the right answer. Clear, right?
Yes, ma'am.
Now coming to question number 9. Determine the number of electron pairs in this reaction, type of rotation, and whether the reaction is allowed or forbidden.
I'm 4 by heat con, 4 pi electrons heating
4 pi electron.
con rotation.
Hmm. Heating means conrotation.
It will be trans to cis.
Hmm. So here if we are doing conrotation, the above one will go outside and the
Yes.
hydrogen
And
will be
down with.
going inside, so methyl will be coming outside. So this is allowed process.
Hmm.
So this was a descriptive mode of question. So the explanation is given here. Why? And we have detailed explain it in the starting of the lecture. So we have usually analyzed this type of reaction from the other direction, that is the conversion of a dye into cyclobutene. However, the same analysis work for either direction of the reaction. So in both direction, formation of cyclobutene from 1,3-butadiene or from cyclobutadiene to 1,3-butene, the mode of reaction will be same. In case of thermal, foreign electrons it will follow conrotation, and photochemical, foreign electron it will follow disrotation. So in this case, an even number, two of electron pairs are involved. The sigma bond and the pi bond of the reactant are converted to two pi bonds of the product. So the reaction occurs by means of conrotation. And according to the chart, that is the Woodward-Hoffmann rules, a conrotation involving an even number of electron pairs is thermally allowed. So the reaction is allowed.
Ma'am, the hello.
Hayati.
Ma'am, the product is in product. Both the methyl group should be in transposition, but here it is in cis. After the ring opening, the methyl groups will be in the transposition.
Yeah,
If you do the conrotation.
right. Both are trans only. EE.
No, sorry, sorry. Both
Hmm?
one will be in cis position, another will be in transposition. Methyl groups.
No, no, you see rotating. If we are rotating in this fashion, see in this fashion, so the hydrogen which
Oh, here. Okay, 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 okay. I
it will
understand.
go
I
inside,
understand. Yeah.
and the methyl which will be above, it will go outside. So same, right? Hmm. So that is all about question 9. Now coming to question number 10. So this is also similar type of question. So indicate the number of electron pairs and the type of rotation for this reaction and determine whether each is allowed or forbidden. So this is H nu case.
4 pi
Hmm.
4 pi इलेक्ट्रॉन हीटिंग के केस में मतलब डिसरोटेटरी.
So this is photochemical condition. So it will be disrotation. And if we consider disrotation, if we move this ideal group in this fashion, it will go above the plane. And in anti-clockwise fashion, if we rotate it, it will go above the plane. So this is the product. So it is allowed, right? If this is foreign electron system and the condition given is photochemical. So under photochemical condition, foreign electron system will undergo disrotation reaction or disrotatory mode of reaction. So in disrotatory mode of reaction, if one of the group is moving in clockwise direction, the other group will be moving in anti-clockwise direction. So here, if the ideal group is moving in clockwise fashion, it will come above the plane. And this also, it is moving in anti-clockwise fashion, it will come above the plane. So both are above the plane that we as written in the product. So it is an allowed process, right?
Yes, ma'am.
Okay. Now coming to the second part of this question, B part. What is the number of electron pairs involved, type of rotation, and if it is allowed or forbidden?
6 pi electron.
Hmm.
Under thermal condition, stereochemistry will be same. Means it should be cis
Huh.
methyl and
So
ethyl group. It should
here
be
it
same.
is, this reaction, whatever reaction
Is
they have
forbidden.
known is forbidden.
Yes.
So 4 pi electron system, it will follow disrotation, right?
Under thermal conditions,
Yeah, under thermal condition, 4 n
and
plus
there
2
will.
disrotation, 4 n plus 2 will follow disrotation. So if it is moving in this fashion, as we have seen here, The cedial group will be going above the plane and medial group will be also going above the plane. So the actual product we should get is both are above the plane or both are below the plane.
Yes, ma'am.
So this product whichever they have given is incorrect. So this reaction whatever they have given is forbidden according to Woodward-Hoffmann rule. Okay.
Yes, ma'am.
Okay. Now coming to the next question. The following reaction involves a is it a photochemical 10 pi electrocyclic ring closure, thermal 6 pi electrocyclic ring closure, thermal 10 pi electrocyclic ring closure, or photochemical 6 pi electrocyclic ring closure? You have to see the stereochemistry of that of this.
Ma'am, is it possible that both the system reactant and product both have 3 to 5 means 5 pi bonds?
Hmm?
This question was in reactant as well as product,
Hmm.
both the system are containing 5 pi bonds.
Yeah. So we will be considering the whole system while giving.
Yeah,
Hmm.
that is correct. This question also came in last day problem solving session, and there was a something error in question, I think.
I am also noticing it now. When there is a double bond, we cannot show the stereochemistry now. So it is
Yes.
just some shift in double bond is there. 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7, 5. So here hydrogen in PHME. So it will be like
कृष्णा थिंक सोचो थोड़ा सा.
I think question is mistake. Maybe one more.
Yeah, this was the same problem last day.
Hmm. Okay, let's ignore this question then. I will remove this
Ma'am,
question while uploading. Okay, I think question is mistaken.
all these slides are uploaded somewhere, ma'am.
I will upload it after class, and Google
Uh,
Drive link will be shared.
okay, ma'am.
Okay, this question we can ignore. So this question itself is wrong. Now coming to another question. So this is the starting material, and here we are applying photochemical condition.
Hmm.
Photochemical condition. So what is the final product that will be forming? So which mode of rotation it will follow, or which number of electron system it is?
6 pi electron con rotatory in case of photochemical condition.
Hmm. So it is a 6 pi electron system, and it will follow con-rotatory mode of rotation, photochemical, according to Woodward-Hoffmann rules. So if we are seeing this part, just consider this part alone. So the system will be like both medials are inside. Okay,
Hmm.
and we will do conrotation. So this medial will be going. See, this hydrogen will go above the plane if we do conrotation, and this medial will also go above the plane. So the product will be like Hydrogen is going above the plane, and here the methyl group will be below the plane, and in this case the methyl will be going above the plane and hydrogen will be below the plane. It will be like the final product, right?
Yes, both methyls will be coming trans to each other,
Both
most
methyls
probably.
will be coming trans to each other. So this is the final answer. So H nu 4n plus 2 conrotation according to Woodward-Hoffmann rule, and we will get the stereochemistry of the methyl groups trans to each other. So it can be either this is alpha, this is beta, or this is beta, this is alpha. Both are possible. Okay.
Okay, ma'am.
And the next question is, show how heat or light can be used to carry out the transformation shown below. So here initially both the methyl groups were trans, and applying two photochemical condition it is converted to both cis. So if I am labeling it like A, B, C and D, what will be the right option?
Lighting pin bond.
1 second.
B should be correct option, ma'am.
Huh?
B should be the correct one.
B, yeah.
No, no. What?
Hmm? Try doing it.
It will be B, ma'am. Sorry, C.
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 So in case of C, if we are considering, this is 4n plus 2 delta, right? So it will follow disrotation. 4n plus 2 system, it is 6 pi electron system. So disrotation means, or we can consider this methyl is going outside. So we can consider the other way around. So this methyl group
Yes,
which
C,
was
C,
above the
C.
plane, this methyl group which was above the plane, it is going outside, and the hydrogen will come inside. And here the hydrogen which was above the plane will be going outside, and the methyl group will be going inside, right? And then 4n plus 2 H nu conrotation. If we do conrotation,
Mhm.
both the methyl groups will be coming above the plane, right?
Yeah.
So this is the answer. And if we consider this case, here this is 4n plus 2 H nu, that will be conrotation.
No change in stereochemistry is there, so that would not be the answer.
What?
Oh, proceed, ma'am. You will.
Okay. So this will be 4n plus 2 H nu. It will follow conrotation. So conrotation means this is above the plane. This methyl is above the plane. If we do clockwise rotation, it will come outside. And here the hydrogen, which will be there, it will go inside. So the both methyl groups will go outside of the ring. And then 4n plus 2 delta, it will follow this rotation, right? This methyl group which is outside, it will come above, and this methyl group which is outside, it will also come above. So this is also possible option. This is
Yes.
C.
Okay.
either by doing thermal photochemical or photochemical thermal. Both can lead to formation of the product. Okay.
Okay. Hmm. Hmm.
So here both option answer will be option B and C. Now coming to the next question. For the following condition, predict whether it will undergo conrotatory or disrotatory ring opening. Show a molecular orbital picture to justify your answer. So this is which sort of system?
6 pi electron, 6 pi
4n plus 2. Hmm.
Yeah, 4n plus 2 or 6 pi electron system. So under thermal condition, it will undergo
disrotation.
disrotation. So it will be undergoing disrotatory mode of rotation. So when we will have to explain the molecular orbital picture, you can consider
Remove. Yeah.
it is having overlap of the same orbitals. So for opening that, we have to move it in the opposite direction. One should be anti-clockwise, one should be clockwise. So this is disrotation. Clear?
Yes, ma'am.
Okay. Now coming to last question. This question also like a different part of this question was discussed initially. So what will be the intermediate that is forming in this reaction?
B will be intermediate.
But
B or okay,
option
let
B
me.
will be the right answer. So first it will have to undergo
4 pi
4 pi electrocyclic ring opening.
it conrotatory.
Hmm. Ring opening it should undergo. So for 4 pi electrocyclic ring opening to take place, um, like the electrons will have to move in this fashion, and it will result in the formation of this system. Right. So this is B. Both are same. Then it will undergo 6 pi electrocyclic ring closure leading to formation of this product. This will be 6 pi electrocyclization. So the concept of FMOs and electrocyclizations are clear, right? Do you having any
Yeah.
doubts regarding that? This was our last question. So this video will be uploaded in YouTube, and I will be sharing the YouTube video link uh, in that Excel sheet which might be shared with you. And the lecture slides will also be uploaded in that Excel sheet. There will be separate link for that, which will lead to a Google Drive. Okay. Any further doubts?
Ma'am, I have a question.
Hmm.
Can I share the screen?
Yeah, sure. I
Okay, ma'am.
I will just unshare my screen.
Ma'am, is it visible?
Yeah, yeah.
Uh, can you see the question, the correct statement about the following transformation?
Okay. So AGOH, it is like halophilic sort of. Silver salt will be halophilic, na? Silver will be halophilic, so it can abstract either chlorine or bromine.
Yes, ma'am. This was the confusion that which
Hmm.
halogen it will extract and what product it will be forming.
Hmm.
This is the question that recently came in CSIR Net June 2024, which was happened, which take place in July 2024.
Okay. So here it will be a two electron system, right?
Yes, ma'am. Cyclopropyl cation will be forming after the removal of halogen.
So for two electron means we should consider 4n plus 2, where n
Yes,
equal
ma'am.
to 0, and 4n plus 2 delta will be this rotation.
Yes, ma'am.
Then out of that, bromine or chlorine, which will be.
Ma'am,
Hmm.
I can share some portion from book. This was, I don't know the book name.
Hmm.
2.5 application of ionic conjugated system in electrocyclic system.
Okay.
This is the means example.
The slide is not visible.
Hello.
Hello.
You tell me, please.
Ma'am, see the 29th, which is written on the right side.
Hmm. Hmm.
Here they have taken out Cl,
Hmm.
and in question they and in this question they have means bromine was going out, matlab, as a living group, and in this question they are considering Cl as a living group. I don't understand the concept. Means why? Means which
Okay.
halogen will be going out as a living group in which case?
Hmm. I was expecting like bromide will leave as carbon bromide bond will be more weaker or more labile. Maybe depending upon the different salt.
Br as a living group, that is a means fine.
Hmm.
We know Br is a better living group as
Hmm.
compared to that of fluorine.
Yeah.
So in this case, it was fine. Means
Yeah.
in this case, Br was as a living group and product B was forming as the major product via this rotatory ring
Yeah.
opening.
Yeah.
But I just got confused because here they have considered Cl as a living group.
Hmm.
Salt, does salt will be impact means AgOH or AgClO4, both are Ag plus one salt.
Okay. Maybe the anion that will be forming will have any impact on the impact on stabilizing the cation. I am not very sure. So I will check into that and will get back to you in the next lecture.
Ma'am, again, one more doubt is there.
Hmm.
In
One
above
second, I will just take a
question.
picture
Uh,
of your slides.
okay, ma'am.
Hmm. Please share the previous slide also. Okay. I will look into it. Okay, why it is happening like that.
Okay, ma'am.
Hmm.
Please have a look at above question also. It was giving a trans product. It should be like a cis product, I think. Means as of my view. Ma'am, please have a look.
Yeah, I will check into this and get back to you. Okay.
Okay, ma'am.
Hmm.
Okay, ma'am.
Okay. If you are having any further doubts, you can share. Like we can discuss in the next lecture probably.
Okay, ma'am.
Hmm.
It's fine.
Okay.
Thank you, ma'am.
Okay. Thank you. Anyone having any other doubts? So in this week, majorly we were discussing regarding the electrocyclic ring opening and ring closure reaction based on thermal and photochemical conditions. So and how the Woodward-Hoffmann rules are derived based on the Frontier Molecular Orbital diagram. So if you are having any doubts on the theoretical concept, you can ask. So the questions we have discussed today is clear, right?
Yes, ma'am.
Okay. There are no further doubts. We can end today's session.
Okay, ma'am.
And I will look.
Ma'am,
Yeah,
in the assignment number 4, problem number 4, if you discuss something about it, then it will be very helpful.
let me check once.
First assignment it is.
Oh,
First assignment, yeah.
okay,
Okay.
let
I have also some doubt, but let's see.
like I am not supposed to discuss those questions completely. Maybe I can give some hints.
Yeah.
Okay, 1 second. Explain why 1,2,4 tri-tert-butyl benzene readily photoisomerizes the corresponding divar benzene. That is the question, right?
Yes.
1 second. Okay, I think you can explain it based on the steric steric hindrance factors.
I also think so that it is a sterically hindered molecule.
Hmm.
So just to clarify it, I am asking this.
Based on steric hindrance only, you can explain that.
Ma'am, it will be like in case of benzene, all three tertiary butyl groups would be in the same plane.
Hmm.
There will be case of a steric hindrance, which will,
I didn't get what you are asking.
means in that question, which is in assignment question number 4.
Yeah.
In case of a benzene type,
Hmm.
means not in divar benzene,
Hmm.
all three tertiary butyl groups are in the same plane, which will cause
Benzene, na. So it is planar only. So it will be in same plane only.
when in case of divar benzene,
Hmm.
these all three tertiary butyl groups will be going in a different planes.
Hmm. Hmm. Yeah.
So that may be the reason the reaction is going forward and making divar benzene.
Hmm. Hmm. Yeah, you are right.
So product is more stable as compared to that of reactant.
Hmm. Hmm. That is the reason only. So you can explain it accordingly.
Okay, ma'am.
Detailed explanation I can give in the next lecture because I am not supposed to, because this assignment will be considered for marking, right?
Yes, ma'am. It's
Yeah.
ethically
And
not
ma'am,
correct.
Yeah.
okay, ma'am. And another question is number 5. Using FMO method, derive the selection rule for electrocyclic reaction involving 4 and 6 electron system.
Hmm.
So here, can we take example of butene and hexatriene system, and then we will
Yeah.
draw the molecular orbital picture, and accordingly we'll
Yeah,
derive.
you have to see the homo, then accordingly that
Yeah.
notation that as I have discussed regarding monthly butadiene, similarly you can
Hmm.
do.
Okay, and ma'am, in other questions, I mean in the number 1, number 2,
Hmm.
it is clearly say that identify the product.
Hmm.
But in the assignment, can we show the mechanism, or only we'll write the product?
You can give detailed mechanism also.
Okay. Thank you.
Okay.
Okay, ma'am. Thank you, ma'am.
Thank you. So maybe assignment one questions we can discuss in next lecture.
Okay,
While we will
it's
be
fine.
speaking. Okay.
Okay, ma'am.
Hmm. Thank you.